Hello, hello, hello. If you are getting my voice, hello, good morning. Class, good morning. All of you are getting my voice. Okay, so today we will discuss about the TCP protocol basically because we have last time we have discussed about the user datagram protocol, that is UDP, clear? And now in the today's lecture we will discuss about TCP, then ATM, clear? And in the last we will discuss about the session layer design issues, clear as well. So before going to start, we can see the basic information regarding TCP and the difference between UDP and TCP. That is very much important, clear? So if I talk about the major difference between UDP and TCP, so first of all, both are belonging to the transport layer protocol basically, clear? And they are generally preferred for the data delivery, clear, or packet delivery, clear? So in case of UDP, the establishment of the connection establishment is not there before the packet transmission. It is a type of connectionless protocol basically, and in case of TCP, it is a very much connection oriented protocol. Clear? So before the data transmission takes place, the connection establishment is very important. So establishment of connection takes place before the data transmission in case of TCP. The last one is SCTP, that will be discussed later on after the TCP protocol. So we will. Okay, so this is what, this is how, again I'm sharing, I think. Okay, so this exactly tells about how the data delivery take place in the basically transport layer and data link layer and network layer protocol basically, clear? So we can see if the communication is between two routers or host to router, clear? So you can see there is a computer host and there is a router. So computer host and routers both are working as a nodes, clear? Individual nodes. So if the communication is done between host to router or router to router, so it is the type of node to node communication. While if we talk about the communication between this host, that is the computer system this, and this is another computer system, अगर इनके बीच communication होता है तो it is a host to host communication. And if the communication is done between this process and this process, so it is called process to process communication, clear? So I have given you a question in your tutorial as well, how the data transfer takes place, what are the different types of data transferring schemes in different OSI layers. So basically you can draw this diagram and mention the points that the nodes to node communication is between that belong to the data link layer, host to host communication belong to the network layer, and the process to process deliveries for the transport layer, clear? So the last one to last one communication is the first one to last one communication is the process to process Computer to computer communication is the host to host, and computer to router communication is what exactly node to node communication, or to router is also node to node communication. So now this is how the communication takes place basically. Clear? So left one is the daytime client and right one is the daytime server. Exactly, there is a communication between the client and server with the transport layer delivery. Clear? So it is a type of process to process communication. Here you can see the multiple datas are there at the client side and server side. They belong to the port number 13. Clear? Also the data is getting from this basically client to the server end with the port number 13. Clear? And this is the sequence number basically, and the daytime server also respond with the same sequence number and the port number for the data acknowledgement. Clear? So now this I have already told you how the communication is done. Clear? With the help of IP header in the transport layer. Clear? So these all have been discussed in the previous lecture. So I will move to further. This is how the multiplexing and demultiplexing takes place. You can see in the TCP protocol basically. We have different processes over here. We have different data or processes over here. They all are combined with the multiplexer basically. And then it is going to the it is communicated through the IP address. Clear? Basically, it can follow the IP protocol or the transmission scheme. So now it is going to the receiver side where this IP is again demultiplexed, and through the demultiplexer and the process got received. Clear? So this is how the multiplexing and demultiplexing achieve in the client server data transfer. Clear? Now this is how the error control mechanism is there. So if you see, the red marked routers are basically used for the error checking process. Clear? They are in the path of the data link layer, and they are responsible for the error checking if anything happen. Clear? And if you see the black mark portion, that is like this is the black mark portion where the error is not checked in this part by the data link layer. So here the black strip exactly represent the error is not checked, while the red strip exactly represent the error checking basically in the data transferring. Clear? So this is how the communication takes place, and error control mechanism is there. So this is how you can place the UDP and TCP as well as SCTP protocol in the TCP IP suite. So this is the TCP IP suite. It is several times asked in the examination. How we can include the transport layer protocols basically in the TCP IP suite. So you can see this is the complete TCP IP suite where we have included this transport layer protocol, that is SCTP, TCP and UDP in between the this TCP IP suite. So these are application layer. This belong to this protocol, that is SMTP, file transfer protocol, and then TFTP, DNS, SNMP. Okay. Then network layer also belong to IGMP, ICMP, IP, ARP, RARP. Then data link layer and physical layer belong to the underlying LAN or WAN technology for communication. So this is how. Now this is about the UDP. UDP, I have already told you that this is a connectionless and unreliable transport protocol, because in this basically the communication is done through connectionless process. So it is a type of unreliable protocol. Here the packet may get lost in between the communication. Clear? So it does not add anything to the service of IP except to process communication. Clear? Am I listen to all of you properly? Am I
Yes,
audible to
sir.
all of you? Okay, okay. So this PDF is I have already shared you, I think. Clear? So you can access on the Google Classroom as well. Belong to this UDP TCP protocol basically. Clear? Now you can say these are well-known ports used with the UDP. So these are the ports used by the UDP protocol basically. You can see there are several ports number, that is 7, 9, 11, 13. They belong to the protocols basically. and different protocols, and they are having some description regarding that. Clear? So you need to learn with these port numbers that are well known port numbers for the UDP. Clear? So these are some. So now this is very important term. This is the user datagram format in case of UDP. So you can say there is a header of 8 bytes, then it belongs to the data on the to the next of that. Clear? Now the header is further classified into source port number. These are the these are called the subfields exactly. Clear? So 8 bytes of header is further classified into the four fields. That is source port number of 16-bit, destination port number of 16-bit, total length is 16-bit, and the checksum field is 16-bit. Clear? So total length of the datagram is 16-bit, and the checksum is basically what? It is used for the error control. Clear? So error control and detection mechanism. Clear? So the strength is quite low. Okay, so now the UDP length, if we talk about the UDP length, clear? So UDP length can be calculated by the IP length minus IP headers length, clear? So internet protocol length minus internet protocol header length will give you the UDP protocol length, clear? So this is what how the pseudo header for checksum calculation is there. Means this is the format for the error control mechanism with the pseudo header. Clear? As well as header. Clear? So header includes these yellow color marks which I have already discussed you in the previous slide. Clear? While the pseudo header is the upper portion. Clear? That is 32-bit source IP address, 32-bit destination IP address, then all zeros, 8-bit protocol of 17 bits, then 16-bit UDP total length, and that included a header also on the bottom side, and also the data that must contain the padding bits, which is added to make the data a multiple of 16 bits. So padding bit just add an extra bits that are added to complete the information. Clear? When it is necessary. Now if we now we come to TCP protocol, basically it is a type of connection oriented protocol. Clear? It creates a virtual connection between two TCPs to send data. So it is very important. So before communication takes place, there is a virtual connection establishment between two TCPs to send the data. In addition, TCP uses flow and error control mechanism at the transport layer as well. Clear? So in this topic, we will discuss TCP services, TCP features, as well as segment a TCP connection, flow control, and error control. Clear? So here you will see the TCP connection is a very important part of this particular topic. Clear? It follows exactly a type of three-way handshaking. So I will tell you later on. So these are the well-known ports used by the TCP. As in case of UDP, I have already told you in the just previous slide. Clear? These are the ports belong to the TCP protocol. Basically, you can see that some description regarding the port numbers, so you can learn also these things. Now, this is how the stream delivery takes place in the TCP protocol, or we can say between the TCP connection, how the process transmission takes place. So there is a sending process and there is a receiving process. So they can make the establishment of they can make a connection establishment, then the stream of bytes takes transfer takes place through this communication medium. ठीक है? जैसा भी आपका ये communication medium है, इसी के through आपका communication will happen. Clear? Now, this is how the sending and receiving buffers takes place. So buffers exactly belong to the memory. Clear? Exactly. So this exactly save stores the data which is sending or receiving at the server end. Clear? So before client server transmission takes place, the buffer exactly required to store the data which is in the queue or which is just need to process. Clear? So you can see there is a buffer on the TCP sending process and there is a buffer on the TCP receiving process. So clear? So the next byte which is going to receive, that is exactly send. This is the next byte you can see, which is going to send, and this is the next byte which is going to receive. Clear? So this is a type of buffer where you can store the stream of data. Now you can see how the segments can transmit it. Here you can see here the segments are transmitted like this. Clear? So these are the individual segments belong to the individual data, and these are the segments which are receiving at the receiver buffer, receiving buffer. Clear? So the bytes of data being transferred in each connection are numbered by TCP. जो भी हम लोग bytes of data transfer कर रहे हैं connection में, वो उनको numbering करते हैं TCP के through. The numbering start with a randomly generated number. जो numbering का मतलब है we assign a particular sequence number randomly that ranging from 0 to 2 की power 32 minus 1. जीरो नहीं अलॉट करते हैं, क्योंकि जीरो अगर हम अलॉट करेंगे तो और भी बाकी जो सेंडिंग प्रोसेसेस होंगे वो भी अगर जीरो अलॉट कर देंगे तो द सीक्वेंस नंबर विल बी सेम फॉर द all. Clear? So it will create this type of collision. So we need to avoid this type of scheme. So जीरो से ऊपर आप कोई भी नंबर रैंडमली कोई भी सेंडर यूज कर सकता है, जैसे सीक्वेंस नंबर. क्लियर? So these are what the sequence number for each segments. You can see segment 1 uses the sequence number in the range of 10,001 to 11,000. Segment 2 uses the sequence. Segment का मतलब है कि बेसिकली जैसे हम जो भी डेटा भेजते हैं उसको एक बड़े डेटा को हम छोटे छोटे सेगमेंट्स में ब्रेक कर देते हैं. क्लियर? सो छोटा छोटा जो सेगमेंट्स बनाते हैं मेमोरी का, उसको हम सेगमेंट्स बोलते हैं. क्लियर? तो सेगमेंट 1 में हमारा जो डेटा है उसको हम सीक्वेंस रेंज दे सकते हैं 10,001 से 11,000. ठीक है? रैंडमली उसमें कोई भी नंबर आप दे सकते हैं 10,001 से 11,000. सेगमेंट 2 में भी आप कोई भी सीक्वेंस नंबर दे सकते हैं, उससे ऊपर 11,001 से 12,000 के बीच में. ठीक है? ऐसे 5 सेगमेंट टोटल हम लोगों ने बनाए हुए हैं. ठीक है? तो टोटल जैसे 15,000 तक ले रखा, तो 10,001 से 15,000 के बीच में कोई भी सीक्वेंस नंबर रैंडमली यूज कर सकते हैं. सो द वैल्यू इन द सीक्वेंस नंबर फील्ड ऑफ ए सेगमेंट डिफाइन द नंबर ऑफ द फर्स्ट बाइट डेटा कंटेंट इन दैट सेगमेंट. क्लियर? तो जो भी सेगमेंट है वो डिफाइन करता है नंबर ऑफ फर्स्ट डाइट बेटा इन segment in that particular segment. Clear? So the value of the acknowledgement field exactly in a segment define the number of the next byte a party expect to receive. Acknowledgement number is cumulative. अब जो acknowledgement आएगा, जैसे मान लीजिए सेंडर ने कोई डेटा सेंड किया, ठीक है, रिक्वेस्ट भेजा या किसी सीक्वेंस नंबर से, तो जब रिसीवर भेजेगा तो रिसीवर विल एक्नॉलेज विद द पर्टिकुलर नेक्स्ट बाइट. क्लियर? सो उसमें ऐड करके भेजेगा, +1 जैसे भेज दिया, एक्नॉलेजमेंट में +1 लगा दिया, सो इट विल जस्ट वांट टू रिसीव द फर्दर डेटा. क्लियर? एंड द प्रीवियस वन इज ऑलरेडी एक्सेप्टेड. क्लियर? अभी मैं दिखाऊंगा इसमें. दिस इज द टीसीपी सेगमेंट फॉर्मेट. दिस इज वेरी इंपॉर्टेंट. ये आपको पता होना चाहिए, इसको आपको लर्न करना पड़ेगा. So this is the TCP segment format, includes again the header and data. Header is further classified into source port address, destination port address of 16 bits. Clear? Now you can see the source port address is the sequence number is 32 bit, acknowledgement number is 32 bit, header length is 4 bits, then reserved 6 bits is there. Clear? Then URG, ACK, PSH, PST, synchronization, FIN. These are what? These are the fields. The red marks portion is the field. Clear? Then window size is of 16 bits. Window size exactly represent the data जो उसको accept करना है, उसके लिए कितना उसके पास memory है, buffer है. That belong to the window size. Clear? Checksum exactly is 16 bit, which belong to the error recovery, error detection and correction. Then urgent pointer is also 16 bits. Options and padding bits are also added on the bottom side. So this is TCP segment format. Clear? Now that this is the control field, which we have discussed by the red mark portion. You can see these are the control fields. The URG stands for the urgent pointer is valid. ACK is for acknowledgement. PSH is for request to push. RST is for reset for connection. Synchronization is the SYN. FIN is the terminate the connection. Clear? So these are the individual meanings. So you can see these are the description of the flags exactly. So this is how the three-way handshaking takes place. You can say this is very important. In several times it is asked in the examination how the three-way handshaking takes place in the in this particular protocol scheme. Clear? So I think it is clear to all of you. The diagram is clear to all of you. Hello, all of you are listening to me. Hello.
Yes, sir.
Okay. So if you see the connection establishment using three-way handshaking, so there is a client and there is a server. Clear? So client server basically belong to the TCP connection in the TCP type of protocol suite. So there is an active open. So starting कहाँ से होती है कि पहले connection को establish करना है. Clear? The first initial step is to establish the connection. So there is an active open interface on the client side and passive open to the server side. So server is always open, exactly. Clear? So whenever the data is going to available on the client side, so before going to send the data, it exactly process the data. चलिए तो पहले प्रोसेस करने के लिए क्या करेगा वो पहले कनेक्शन को एस्टेब्लिश करेगा किसके किसके बीच में क्लाइंट और सर्वर के बीच में क्लियर सो यू कैन सी when the data is available to the client, it actively opens its port. Clear? So it sends a request with the sequence number. So sequence number is 8000. This is the randomly generated sequence number. Clear? So also it is synchronized with the it sends the synchronization flag. It is the high flag exactly. Syn का मतलब है यहाँ जो synchronization यूज कर रहे हैं this is exactly high. So it just want to make the server also synchronize. Clear? सर्वर को भी सिंक्रोनाइज कर रहा है जिससे कम्युनिकेशन में कोई प्रॉब्लम ना हो. क्लियर? इसमें एक हमारा सीक्वेंस नंबर जो भेजा रहा है दिस इज अ रैंडमली जनरेटेड सीक्वेंस नंबर. क्लियर? सो इसने केवल सिंक्रोनाइजेशन मैसेज भेज दिया रिक्वेस्ट भेज दिया कि वी हैव नाउ द डेटा टू सेंड एंड देन सर्वर को ये रिसीव हुआ. तो इसके बाद एक चीज और ध्यान रखिएगा कि जैसे एक सेगमेंट नंबर होता है. क्लियर? जैसे मान लीजिए इसका विंडो साइज अगर 18,000 है और सेगमेंट नंबर इसने दिया 6,000. ठीक है? तो इसके पास जो भी एक प्रोटोकॉल या एक एक पैकेट रिसीव करने के लिए जो साइज रहेगा वो कितना हो जाएगा टोटल 18,000 अपॉन 6,000. तो मतलब 6,000 से आप डिवाइड करेंगे तो इट विल गिव यू 3. तो इसका मतलब है कि ये मैक्सिमम एक पैकेट इसका जो एक सेगमेंट है वो मैक्सिमम 3 बाइट का पैकेट एक्सेप्ट कर सकता है. क्लियर? इफ द सपोज सेगमेंट नंबर इज 600 एंड द विंडो साइज इज सपोज 6,000, sorry, the segment number is 6,000 and the window size is suppose 18,000. So it basically defines the how yeah, how it can receive a particular byte information. Clear? या कितने अमाउंट का ये बाइट इंफॉर्मेशन रिसीव करेगा. तो आपको क्या करना है 18,000 को 6,000 से डिवाइड कर दीजिए. यू विल गेट 3. सो इट विल गिव यू तो ये बताएगा कि 3 बाइट का हमको एक डेटा एक एक हमको पैकेट चाहिए किसमें एक सेगमेंट में. क्लियर? सो यू कैन सी so this message is exactly sent to the server side. Then the server is exactly passive open. So it will acknowledge this client. Clear? So it will again send the synchronization. Synchronization तो है ही है सर्वर एंड एक क्लाइंट में. तो सिंक मैसेज तो जाएगा ही प्लस एक्नॉलेजमेंट विल आल्सो ऐड विद दिस. क्लियर? हियर यू कैन से देयर वाज नॉट एक्नॉलेजमेंट बिकॉज ये केवल अभी सेंड कर रहा है ये प्रोसेस को इनिशिएट कर रहा है. लेकिन जब इसको रिसीव हुआ ये मैसेज तो इसने एक्नॉलेज किया कि नाउ आई एम अवेलेबल टू रिसीव द डेटा. क्लियर? विद द same synchronization process. Clear? So you can see it received the acknowledgement. Sorry, it received the acknowledgement at the client side. It received the acknowledgement by the server. Clear? So with the sequence number again 15,000. This is also random generated sequence number by the server now, and this is the random generated sequence number by the client. Clear? So acknowledgement is now 8,001. इसने एक्नॉलेजमेंट जो एड्रेस भेजा दैट इज 8001 से इसने बताया कि नाउ ये भी एक तरह से रैंडम ही है, तो इट इज नाउ अवेलेबल। नाउ जब ये एक्नॉलेजमेंट इसको मिल जाएगा, इट विल फर्दर सेंड द एक्नॉलेजमेंट, इसने फर्दर एक एक्नॉलेजमेंट भेजा कि नाउ द मतलब कि हाँ आपका मुझे ये रिस्पांस मिला है, नाउ आई विल सेंड द नेक्स्ट डेटा। तो ये नेक्स्ट डेटा के लिए रेडी हो जाएगा कि ये एक डेटा इसका कम्युनिकेशन में के लिए रेडी मतलब कंप्लीट हो गया। नाउ इट विल सेंड द फर्दर डेटा, सो इट विल अगेन सेंड द एक्नॉलेजमेंट। क्लियर? सो इट इज हैविंग द सीक्वेंस नंबर 8000। ये आप 8001 भी ले सकते हैं बेसिकली, क्योंकि अब नेक्स्ट डेटा ये सेंड कर सकता है। ठीक, एंड दिस इज द एक्नॉलेजमेंट बेसिकली दैट इज 15001। सो this is how the communication takes place using three-way handshaking. So basically in general we can say this is sending sync message, this is sending sync plus acknowledgement, and this is again sending the acknowledgement. Clear? So a sync segment cannot carry data but it consumes one sequence number. ये भी ध्यान रखना है, जो sync segment हम लोग भेजते हैं वो कभी डेटा को कैरी नहीं करता, but it consumes one sequence number. Clear? A sync plus acknowledgement segment cannot carry data, but it just consumes one sequence number. Clear? The acknowledgement sequence it carry no data, consumes no sequence number. Clear? Now you can see this is how the data transfer takes place. When the once the connection is established, अभी पीछे हम लोगों ने जो किया था वो connection establishment था, अब data transfer होगा. Data transfer is again a three-way type of handshaking. So when the connection is established, now it can send the data. Clear? So you can see when the client is now sending the data with the data bytes of 8001 to 9000. Clear? It is received to the server. Clear? Also, it sends the data basically 15,001 with the data between 9,001 to 10,000. Clear? Then the server will respond again with the sequence number 15,001 and acknowledgement with the 10,001. Clear? So this is the data bytes range, that is 15,001 to 17,000, and then again the client will acknowledge this particular message that is received by the server end. So this is how the data transfer takes place. Clear? This is how now the when the data communication is over, so the connection termination will be there also with the three-way handshaking process. So this is how the connection termination takes place. There is a client, there is a server. So it will send now the active close message. पहले एक्टिव ओपन था, अब एक्टिव क्लोज मैसेज भेजेगा ये टर्मिनेशन को, मतलब कनेक्शन को टर्मिनेट करने के लिए. क्लियर? सो यू कैन सी it is now sending the active close message. Clear? So active close में क्या होगा, एक मैसेज कन्वे होगा with the sequence number X and acknowledgement Y. You can see. Clear? With the fin flag. This is the fin flag that is used for the termination purpose. Clear? So fin flag will be high. This represent the termination of the connection. Connection का termination को represent कर रहा है ये. So sequence number भेजा X, acknowledgement Y भेजा. It is again received to the server end. Clear? With this passive close is also there on the server end. At the active close is on the client end, and server will be on the passive close side. Clear? So it will again send the fin plus acknowledgement. जैसे पहले हम लोगों ने जब कनेक्शन स्टेब्लिश किया था तो सिंक्रोनाइजेशन प्लस एक्नॉलेजमेंट आ रहा था, वहां पे कनेक्शन स्टेब्लिश हो रहा था इसलिए सिंक मैसेज आ रहा, सिंक फ्लैग आपका वन था. यहाँ कनेक्शन क्लोज हो रहा है तो फिन आपका वन हो जाएगा. तो फिन प्लस एक्नॉलेजमेंट विल बी रिसीव ऑन द क्लाइंट साइड. Clear? With the acknowledgement. Okay, so someone is have not mute their audio, so kindly mute, or all of you are requested to kindly mute yourself. Okay, so now the server again sent the fin plus acknowledgement to the client side. Clear? Again with the acknowledgement that is X plus 1. You can see this sequence number is now converted into the acknowledgement plus 1 by the server, and this acknowledgement is now converted into the sequence Y. Clear? So you can see here now again it is sending the acknowledgement that now I am ready to terminate the connection. So it will send the acknowledgement whenever it got the proper information with the server that which whatever message I have delivered with I have got the same response, then it will just terminate the connection thus by sending the acknowledgement, that is y plus 1. So you can say again that this sequence number is further used in the acknowledgement plus 1, and this sequence number x is further reduced by this acknowledgement, that is x plus 1. Clear? So this is how the connection termination using the fin segments exactly consumes one sequence number if it does not carry data. Clear? The fin plus acknowledgement segments consume one sequence number if it does not carry data. So you see, this is half close communication is done. So half close में क्या है? You can see this particular portion. You can see here the data segment from the server to client and acknowledgement from client to server. So this is what dark says. This is shadowed portion where the half communication takes place. Means half communication is closed exactly. Clear? So this is the sliding window basically. Sliding window exactly saves the data for being lost. Clear? So this is having a particular window size. So ये क्या करता है कि जैसे मान लीजिए जो डेटा हमको जिस टाइम पे ट्रांसमिट करना है तो उसी डेटा को पर्टिकुलरली सेलेक्टेड करेगा और उसी को ट्रांसमिट करेगा. तो जितना भी ये विंडो स्लाइड करता रहेगा, बीच का जो विंडो आपको दिख रहा है इट इज स्लाइडिंग टाइप. सो जिधर भी आप स्लाइड कराएंगे उतना डेटा आप सिलेक्ट करके और ट्रांसमिट कर सकते हैं. क्लियर? So this is a type of sliding window. So in sliding window is used to make transmission more efficient as well as to control the flow of data so that the destination does not become overwhelmed with the data. तो इससे डेस्टिनेशन कभी भी ओवरवेल्म नहीं होता है, मतलब उसके पास एक्सेसिव डेटा कभी नहीं आता है, क्योंकि जितना आप डेटा चाहते हैं ट्रांसमिट करना, जितने की अमाउंट है उतने को आप सिलेक्ट करके ट्रांसमिट कर सकते हैं. क्लियर? So it just avoid the drop of the data, you can say. Clear? So TCP sliding windows are basically byte oriented. Clear? Now these are some example, we can discuss it later on related to that. So some points about TCP sliding windows, you can see we are having some further points, you can read it from here. Clear? Now acknowledgement segments do not consume sequence number and are not acknowledged. Clear? So these are some points related to this. This is the normal operation, how it takes place between connection and server, or client and server. You can see. Clear? The client sends the message and the server responds to this particular message with the sequence number, with the different sequence number and plus acknowledgement. Clear? Now it is having some delay for the further transmission, that is 500 millisecond. Then it acknowledge with the message, and then it again get the message from the server end with the less than 500 millisecond delay. It again got the another message with the same, with the different sequence number and acknowledgement number with the and same acknowledgement number, and it again acknowledged to the server. So this is what the normal operation takes place. Now if the communication is fast, clear, अगर communication fast होता है तो most of the time data may get lost in between the transmission. So you can see here the loss of data is there. Clear? Data आपका lost हो गया. So there will be a gap created in the what? Gap यहाँ create हो गया क्योंकि ये वाला data receive नहीं हुआ इसको. तो जो इसके पास बफर था, रिसीविंग बफर में एक पॉइंट पे यहाँ गैप क्रिएट हो गया, एक स्लॉट में गैप आ गया क्योंकि वहां पे डेटा बीच में मिसिंग हो गया था, वो रिसीव नहीं हुआ, जो कि यहाँ लॉस हो गया था. तो इसको हम कहते हैं आउट ऑफ ऑर्डर डिलीवरी. इसके बाद यहाँ मिस हो गया, फिर दूसरा डेटा यहाँ रिसीव हुआ तो यहाँ डेटा आ गया लेकिन यहाँ मिसिंग हो गया. दिस इज आउट ऑफ ऑर्डर डिलीवरी, क्योंकि अब ऑर्डर डिस्प्लेस हो गया, मिसप्लेस हो गया. क्लियर? ऑर्डर आपका क्या हो गया? रैंडम हो गया. ठीक है? तो अगर डेटा अगर कहीं बीच में लॉस होता है तो ऑर्डर विल बी what? Order will be converted into out of order. Clear? So this is a loss segment. So receiver TCP delivers only order data to the processes. So you can see this is the fast transmission. Fast retransmission में ये problem आती है most of the time. The यहाँ पे देखिए जब ट्रांसमिशन, जब फास्ट ट्रांसमिशन किया तो यहाँ डेटा लॉस हो गया, तो फिर से फास्ट रीट्रांसमिशन किया तो वी गॉट द ऑर्डर डेटा, यहाँ पे देख सकते हैं रिट्रांसमिशन में हमको ऑल इन ऑर्डर्ड मिल गए सारे डेटा, फर्दर रिट्रांसमिट जब किया उसी मैसेज को, ठीक है। देख सकते हैं आप ये जो 301 से 400 वाला जो डेटा लॉस हुआ था इसको हम लोगों ने रिट्रांसमिट किया यहाँ पे 301 से 400, दैट इज हैविंग द सेम सीक्वेंस नंबर, so it got the all in order data. Clear? Now SCTP will be discussed further. Clear? And now we cover to the ATM protocol basically. Clear? So one more question is there, that is what is the difference between UDP and TCP? So you all need to take care of this. Clear? So difference between you all need to handle by yourself, और I will say about the एक टॉपिक और है आपका that belong to exactly the session layer design issue. All of you are getting my point? The session layer design issue and the ATM layer protocol in this unit. All of you are getting my point? Hello? सभी लोग, all of you are requested kindly rejoin the session, जिससे ये जो टॉपिक है आई विल कवर इट। क्लियर? जो जैसे ही सेशन अभी एंड होगा तो काइंडली रीजॉइन अगेन। क्लियर? So I am just showing you how the session layer design issues exactly. Clear? So just wait. What are the basic design issues in the session layer? Clear? So I am sharing you. Just wait. So is it visible to all of you? This is visible to all of you. ये सभी को दिख रहा है? हेलो? ये
Yes,
सभी
sir.
को दिख रहा है?
Yes, sir.
Okay, so this is also covered in your syllabus. That is the last topic of this unit exactly. इसके अलावा एक टॉपिक एटीएम है, वो भी हम लोग अभी डिस्कस कर लेंगे। So all of you are requested kindly rejoin. Clear? So this is the design issue in the session layer exactly. Clear? The session layer आप लोग को पता, this is another OSI layer of the 7-layer model. Clear? So physical layer, data link layer and network layer, basically location system. So the communicating system layer related with that. If you go through this role, so dialog can come to be full duplex or hard duplex. So dialog is exactly the message. Clear? So exactly session layer क्या करता है, ये allow करता है दो सिस्टम को कि they can exchange the their dialogues mechanism with the help of full duplex or hard duplex communication. Clear? Full duplex and hard duplex you all already know about this. क्लियर? जैसे जो टीसीपी होता है वो भी फुल डुप्लेक्स मोड पे काम करता है, आप लोग को पता होगा। सो द सेकंड फंक्शनिंग ऑफ दिस सेशन लेयर इज मैनेजिंग टोकन्स। सो व्हाट इज मैनेजिंग टोकन्स? So the communicating system in a network try to perform some critical operation and it is session layer. Clear? So which prevents collisions which might occur while performing these operations which would otherwise result in a loss. So these are basically managing token में क्या है कि जैसे हम कोई भी, हमने आपको जैसे बताया था लीकी बकेट एल्गोरिथम एंड टोकन बकेट एल्गोरिथम। सो एग्जैक्टली इसमें क्या है कि जो भी हमारा डेटा ट्रांसमिट हो रहा है which must have the token particularly. Clear? So which we can avoid the collision. Clear? ट्रांसमिशन के दौरान, ठीक है। तो सिंक्रोनाइजेशन इज द थर्ड पार्ट। सिंक्रोनाइजेशन में क्या करते हैं, वी यूज द चेक पॉइंट्स दैट आर इन द मिडवे मार्क्स that are added after a particular interval during stream of bytes. So check points क्या है, generally check points